And then Lincoln, as soon as she's done, you can hop up here. Gianna's gonna come up here and explain her work for this answer. Guys, ask her questions, she's got it. Gianna, remember, speak to the class when you're talking, okay? Not 2 to the 4th power. It equals 2. She doesn't pay attention. It doesn't make sense to ask, okay? Rest of this is good.
Guess the secret one right there, and right there, and the W and the 2, and then you multiply, so that's 2 to the 2nd power, and then Q to the 4th power, and W to the 2nd power, and then you do that, so 2 times 2 is 4, and Q to the 4th power, and W to the 2nd power.
All right, great job, Gianna. You guys have any questions? I've got a quick question for you, Gianna. Where did you get Q to the power of 4?
2 times 2.
You take that outside exponent, multiply it times the inside exponents. Y'all, please take notice that she put the invisible 1s on the W and the Q, and then she simplified. Lincoln, if you could quickly hustle it up. Lincoln, while you're on your way up, tell us about that 0. What is it going to do to the 2 and to the secret 1?
Makes it 1.
So, give us more, show us.
So you have the secret 1 right here for A, and then you multiply 0 times 2 and 0 times 1, and you get A 0, and then B 0.
Pause there for a second. Guys, this is a mistake that a lot of us made. Let's not make it again. Lincoln, tell us one more time. How'd you get the 2 zeros?
You multiply the outside number by the exponents in the parentheses.
That's the superpower property, the power of a power property. But we're not done, are we?
No.
Keep going.
To then multiply these two together, or no, yeah. So this equals 1, and this equals 1, and 1 times 1 is 1.
The answer is 1 because, good job, the 0 is on everything. And it's not A to the 1 power or B to the 1 power, it's 1 as a whole number. And some students put A to the 1st power and B to the 1st power. The 1 is a whole number. All right, and that brings us to the last rule. You ready?
Mm-hmm.
After we learn this next rule, then it's all practice from there on out. No more new material, just practice. Any questions about the outside power rule? And when we get to the negative exponent rule, we're going to talk more about why 0 equals 1. Okay? Shall we move on? We need a break. Yeah, 1 minute break? Let's take a 1 minute break, okay? Let's take a 1 minute break. Ask you guys to get out of your seat a little bit. Just do a little stretch. Maybe do a little spinal twist. Just get up though, get your blood moving a little bit. Maybe do a quick squat, quick lunge. But definitely stretch right now. Definitely stretch. Reach for the sky, stretch it out because you're going to feel better, you're going to engage better. You good? As soon as this young man comes back, yes. Did you understand what she was doing up here? Yeah. Alright. Are you good now? Okay. It's about 20 seconds left, so really take advantage of this. I encourage you to get up out of your seat. Get up, stretch. Take a second. Say hello to a friend. You absolutely can throw the trash away. Yes, please do. Guys, let's watch the social distancing, please. Try not to get too close to one another. Pump up, stretch. All right, let's return to our seats in 3 seconds. All right, that's time, so let's move on now. I'm going to give you about 1 minute only to set up your notes. This is the only page of notes. And then we'll go over example A, then we'll do B, and then it'll be practice time. So give yourself a moment to take the notes neatly. This is rule 5 of 5. There are 5 rules, and this is the 5th one. So we're done after this as far as exposure to new content goes. Welcome back. Start taking notes, sir. Gianna, very neat. Sophia, all finished with the notes? Okay, great. Appreciate that. Alexander, you taking them on paper or on this right here? Show me where you're writing down them. No, we're not copying them later. We're taking the notes now. I'm okay with you typing the notes, but when we do the examples, that's on paper with the pencil, okay? Where'd your pencil go? You don't know where your pencil went? Just sharpened it a second ago. Here you go. You can type the notes, but you need to write the examples. All right, you should be just about finished setting up your notes. It's only 2 examples, A and B, and then what is that, like 3 sentences, maybe 2 sentences? Excellent to me, very neat. Why is this in the track? Good. Appreciate it. Tammy, got it done? Very good, very good. Like you feeling alright, man? Need anything? Alright. Come on now, guys. I know it's a quick race, but can you read that?
Yes, sir.
Alright, you can read it. Alright, let's talk about the negative exponent rule. Karina, you ready? Karina, how many x's are on top for example A? It says x squared, x to the power of what?
X to the power of 2.
So how many x's is that?
That is 2 x's.
That's x times x, 2 x's. And on the bottom?
4 x's.
Once again, we're showing why it works in example 1. Importantly, what is, say, 5 over 5? What does that have to equal?
1.
That's 1. If you have 5 slices of pizza and you have all 5, you have 1 pizza. It's a fraction basic. The same can be said for x over x. This equals 1 because x goes into x 1 time. The same can be said for the second x over x. That equals 1 because x goes into x 1 time. How many x's are left?
2.
And where are they?
On the bottom.
They're on the bottom. They're in the denominator. So there's our answer. Fraction x squared, because there was 2 x's left and they're in the bottom of the fraction. What are we going to put in on top as a placeholder? 2. Where are you guys getting 2 from? There's nothing left up here. What was x divided by x? Gianna?
Was it 1?
It was 1. So that's going to leave us as a 1 kind of as a placeholder. There's 2 1s, right? But it's not 11. It's not 1 plus 1. What is the relationship between these 2 1s? 1 times 1, which is going to give us 1. So there it is. That's the final answer. But we didn't even see a negative exponent. Now let's take this and let's operate on it. What can we do with 2 and 4 because we're dividing? What's the rule? When you divide, what are you supposed to do with your exponents? Tristan? Subtract. What is 2 minus 4, class? So now we get x to the power of negative 2. You guys have any questions about that so far? And here's where we apply that negative exponent rule. Let's quickly discuss this right here. Here's x squared, here's x to the power of negative 2. We can say comfortably that 2 and negative 2 are opposites. One's negative, one's positive. Let's discuss x squared as a positive. We know it means x times x. Makes sense, it's practical, we've seen that before. But how can you multiply x times itself a negative number of times? Does that logically make sense? How can we multiply x times itself negative 2 times? Exactly, you can't, right? So negatives and positives are opposites. This is repeated multiplication. So what do we think a negative exponent really is telling us? Repeated division, excellent. So when you see a negative exponent, like x equals negative 2, you bring it to the bottom, and it becomes positive. Because this is really telling you 1 over x times x. And now we need to add to our notes. Negative exponents don't mean repeated multiplication, they mean repeated division, which is the opposite. Negative exponents, that means repeated division. So you're going to need to add that to your notes. So when you see a negative exponent, it's not allowed to exist because it's not telling you multiply by x times x. It's actually telling you to divide by x squared. A negative exponent doesn't logically make sense. You can't multiply backwards. But what is the kind of opposite of multiplication? How do you multiply backwards? You divide. So it's an inverse in that way. So I'm going to go back to the original slides. You guys have this? Really critical. Negative exponents mean repeated division. What do we do to simplify them? We take the negative value, take the entire term, and you zoom it to the bottom, and it becomes positive. So on this item, when you have x equals negative 2, you bring it to the bottom, and you make it positive. You put a 1 there as a placeholder. When you consider an example like b, there's multiple things going on. We have 2x to the 5th y squared over 4x y to the 4th. We're going to simplify the fraction to start. This is just like in elementary school. 2/4. What were you going to say, Stefan?
I have a question.
Go ahead.
So for A, why don't you leave it just X to the, oh well, you can't.
What? Go ahead. Say it out loud. It'll help.
You can't do negative X or something times X or something.
The first thing you wrote is negative exponents are not allowed. They're improper. So if you see them, you have to change them. That's why you can't just leave it as x to the negative 2 power. Does that make sense? That's kind of like leaving, like if I give you a question and I'd be like 3 times 2, and you tell me the answer is 3 times 2. It's like, yeah, you're not wrong, but you're not simplified. So, anyway, 2/4. Tell me, what does that equal to? You eat 2 out of 4 slices of the pizza.
Oh, 1/2.
1/2, right? That's an obvious fraction that we can simplify. We're going to start by making that 1/2. Let me switch colors. We're going to start with a large 1/2. Now let's talk about the x values. This is a division problem. Tristan, you told us before. When we divide, what do we do? Subtract. Guys, focus up. This is the last rule. Let's focus up. So how many x's do we have in total left over?
6.
Divide means we do what? Subtract. So it's not 6 in total after we solve. It's, what did you say, Tamala? Louder? 4. X to the power of 4. What about y squared over y to the 4th? We divide, so we subtract. What does that result in? Y to the power of negative 2. But something's wrong. Alexander, what's wrong? The 2 is negative. Read this out loud, young man. If you have a negative exponent, turn it positive by moving the power and base simply to the other side of the fraction. You take it, zoom it down here. What's left in the numerator? What's left in the numerator? 1x to the 4th. 1 times x to the 4th is x to the 4th. 1 is an invisible number. What's in the denominator?
2y to the power of 2.
2y to the power of 2. That's the simplest term. What else can be said here? What else should be said here? You can also do this one other way, where you do expansion method. Expansion will tell you, and I'm just going to kind of write over this, pretend that that's not there. 2x, x, 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 5 x's, x to the 5th power. Y squared, y, over 4x, y to the power of 4, which is y. This is the expansion method. This is not how you're supposed to do it, but it will always work. 2/4, there's your 1/2. Cancel your x value out. What are you left with? 4 x's. Where are they? The numerator, as in our answer. Cancel your y's. 2, what are you left with? 2 y's, and where are they? In the denominator. Does that make sense? Expanded form. You guys ready to practice? All right, cool. Any questions here? When you divide, you subtract, and are negative exponents permitted? No. Okay. Let's practice. Here's 2 questions for you guys to do. On letter C, I want you to expand it out. Show the work, show why the rule exists. Did I already stamp that?